Okay, can I start? Hello, everybody. I'm going to. Thank you. Thank you. Thank you for the invitation, first of all.
Sorry?
Almost there. So I came here to talk about Rails legacy applications and how to turn them into DDD. So how many of you do Rails? How many of you regret doing Rails? Always?
No.
Yeah, sometimes it's okay. How many of you heard about DDD a little bit? Okay. How many of you read the blue book, the DDD book? Heroes, those are heroes. Okay, so I'm going to talk about what is legacy, just to make sure we understand it somehow, why and when Rails applications become legacy application. I'm going to talk about DDD. I'm not going to introduce it because it's a whole book, so it's not enough time to read everything. But I try to explain why it's worth learning, how we can use it in our everyday job, and how to introduce gradually DDD to Rails applications. Yeah, we learned lessons, we made mistakes, so I'm going to share some mistakes with you as well. So I'm working with Rails applications for 11 years now. I'm running a company called Arkansas. I read books, I blog, I organize. This is something interesting. I invite you to come to Wrocław to a Ruby conference. It's a really nice conference, I hope. And we have drag meetups in Wrocław. So if you think you have a funny name, imagine this. We have drag. Yeah. And many people came to sell drugs. Okay, that's the important part of who I am. I reviewed. My job is kind of reviewing Rails applications because we run many projects. People come to us and they try to hand over applications to us, and my job is to review them. But I also review the current ones, so I know them. I also teach students Rails, so I review crappy Rails code written by one-week Rails developers. Yeah, but usually we deal with big Rails applications. So the things that I'm talking to you today are mostly applied to big applications, not really to 10-minute block applications. So what is legacy code? Who can tell me? Any definition, any characterization of what is legacy code?
Code without tests.
Yeah, Michael Feathers.
Hard to maintain.
Hard to maintain.
To-do command.
To-do command, yeah. Yeah, people don't have to-do management tools, right? They need to put it in the code.
3 years last to me.
Sorry?
3 years ago last.
Yeah, time related. Yeah, when was that? Yeah. Okay, so this is one way. Framework related, nobody said that. Monolithic, no architecture, no tests. So no test is probably the most classic definition. If it has no tests, it's a legacy. Here are some more common expressions. Code written yesterday, somehow. Code written by someone else, by definition. So not my code, not in my favorite architecture, right? So if I'm going to talk about DDD today, by definition, if you don't do DDD, you have your all right legacy code. So how do Rails apps become legacy? Tell me your stories. Juniors? Or is it you? Everyone. Rails fault or developers fault?
Developers, sorry.
Customers, yeah. Shitty customers pay money and they expect anything. Rails is optimized for first weeks of development. It's me. I made up this quote. But that's my observation, because Rails brings us joy and speed in the beginning of the project. The customer is actually happy. Later, they're always sad for some reason. At the beginning, they're happy. They're contacting a Rails developer, and everything's fast, and the first week is great, and the second week is great. They're falling in love. But later on, so Rails is optimized for adding new forms, new tables, new columns, new views, because that's what we do with our applications at the beginning. And this is the part of Rails that I'm not hating. I'm okay with that. I'm actually recommending Rails for this. The part where Rails is actually not optimized for is complex business logic, which sooner or later appears in some long-living Rails applications. This is the part where we don't care about everything being so nice that we create a Rails model and automatically we have the column names appears as fields, because we are no longer adding so many new fields. I actually ran some statistics at some point that I took a number, dozens of GitHub repos, and I saw the changes, like the DB schema, schema RB, how often it's changed. So after some time, it's actually not changing, because you are changing the behavior of data, but you are not often changing the data itself. Like, I work on a ticketing platform, and I believe that everyone sooner or later works on a ticketing platform. Somehow it's a really specific business. Refunding a ticket. Someone bought a ticket to an event. We did some interesting things in our application, and then they request a refund because they don't go there, because they just want to make fun from us. Whatever reason, but refunding a ticket in a complex ticketing platform means a lot of things. It's applied to finances. It's applied if you, for example, if you have a rule that after attending 10 events, you become a VIP customer. So if you attended the 10th event, but then you canceled your attendance, are you still a VIP or you are not? So interesting business things to consider. What are the symptoms of a Rails application becoming legacy or a bad shape? We could probably have a huge list. Slow tests. The setup for the test is long and complicated. So you want to test like something about the ordering the ticket, and before you can actually go to the state with your test, it's like ta-da-da-dum, and then you create some test utils classes, you create some test actors, and there's a whole lot of things just to set up, and then to run, the customer refund a ticket. And then you have a lot of assertions. Critical bugs are more often. So in the first weeks of development, we rarely do bugs because it's all conventional configuration. We don't have too much code, so it's okay. Slower development progress. Suddenly, customer is no longer sure that they love you. It's a complicated relationship. It's all complicated then. Inside your team, you are no longer sure you love your team member. How could they actually introduce this new controller? There was no reason to that. How could they add a new method to a model class? We know there should be no logic in the models, right? So conflicts. My friend calls it that Rails has infinite API, Rails apps. I don't mean HTTP API, I mean the internal programmatic access. Because we use models directly, models have those associations. Associations generate methods in a way. So we have an infinite way of accessing our applications. So it's not easy to say. Rails is this nice place where you're not really sure how your application is used. Okay, so DDD, domain-driven design. DDD aims to help the complex business problem. It's very popular in the .NET world, very popular in the Java world. Surprisingly, it's popular in the PHP community. It's not popular in the Rails community. So I'm surprised that it's good that you all heard about it, but applying DDD in Rails applications is still something not so common. I'm not saying it should be common, I think it's an observation here. I think that mostly we don't want to do DDD because we relate all the architecture stuff to Java, and we have like the DNA in our community that we hate everything about Java. So you just mention XML, and everyone, XML is almost like Java, so no, we hate it. Why it's worth learning DDD? From our perspectives, you have more new techniques to use, new tools. It's a solution to complicated business logic. This is solution in non-Ruby worlds. Suddenly we are opening our design problems. We can enter a new world where .NET people and Java people discuss how to implement a ticketing platform, which we can't do right now because they don't understand Rails specific language. And you know what? All the specific Rails language that what we are introducing it's always like a bit different than the other parts of the word define it. Like we call something functional tests, and all the other words calls it differently. So we now have shared language with other programmers. That's good. Not only Ruby programmers, not only Rails programmers. And the last thing is maybe the most important for many, microservices. So the thing I'm going to talk about is enabling us to do better microservices. But it's not a requirement to do microservices. It's just, okay, how to start with DDD? I learned that service objects are the gateway drug. Who is using service objects in any shape? Great, you're almost addicted now. I've seen like 12 shapes of a service object. So we all understand service objects differently. I'm sorry. But this is a good introduction. So you are starting to introduce some layers in your application. That's a good starting point. Now, strategic versus tactical DDD. The book about DDD, the original book, is very big. And many people, me included, start from the beginning. We read some beginning chapters. And we learn about tactical DDD. And it's so great. Services, repositories, value objects, aggregates. It's so great that we think, okay, the other parts of the book are not so important. I learned everything now, so I can apply. So we learn about layers a lot. And Eric Evans, the author of DDD, he actually says that he regrets one thing, that he didn't change the parts of the book. He should have started with strategic DDD. To understand what is tactical DDD, I will repeat the mistake and start with tactical. Tactical DDD. So there are some concepts: entities, value objects, aggregates, domain events, services, repositories, factories. We probably use them. It's good to read those definitions, but I'm not going to focus too much. The thinking in aggregates is useful. Aggregates as the object with some other objects connected to it, so as something like user with projects, or project with tasks, customer with address. That's the aggregate. So always something with something. So this is now a bit new tool to think. In Rails, we always think about every model as a model. So blog post, comment, doesn't matter. It's a model. We just find the model, and that's it. This is called DDD Lite, also the tactical parts of DDD. And the whole flow is more or less like this. There is application service at the top. It can call domain services or use aggregates directly. You can do something cool with the aggregate. So imagine we are loading the user with the projects, for example. So we are loading it to the memory. We do something cool, so maybe we are adding a new project. Maybe we trigger insert domain events, like project created. This is an event, we can publish it. And then we save the aggregate. So we get the user object with projects. Those are not active records usually. We pass it to the repository, and we say save it. That's simplifying a lot of things. That's the idea. Putting it differently, we have in Rails application URL, Rails action. So Rails action, the controller calls the application service, then we call domain services. Then we use repositories, and we use active record internally, and it saves to the database. So one application service can call multiple domain services or can use many aggregates, to put it differently. For example, when we were turning this ticketing platform into more DDD layered approach, we turned one thing that was a customer/update. Actually, that was different. This is an example. This is an example that this is actually, usually when you have a Rails action called update something, it means a lot of actions, because we are batch updating from the web request. In one project, we had extracted 15 domain services from one request. So I think that was update event in the ticketing platform. And update is always hiding a lot. Create is also hiding a lot. So we think in terms of the requests, but there are more fine-grained operations. This is the difference that Uncle Bob often explains. You have your domain code, like in the ticketing platform, it's all about tickets, events, and so on. And there are some operations like order ticket, for example, or refund a ticket. That's a domain service, or change email address. But the application is like, so this is like the middle, and the application is like above it. And the application is very specific to Rails, for example, to HTTP, that you are using some batch params, you're getting some batch params, and then you are doing some actions with that. And Uncle Bob suggests, and this is also what DDD does, suggests to splitting this code. So domain code can be reused in other environments. You can use command line interface. You can use, if you're anyone using RubyMotion for mobiles, almost. So you could reuse it for RubyMotion. Anyone uses OpalRB, JavaScript Ruby? You could reuse it in there because it's just the middle. It doesn't know about persistence, for example. It doesn't know about the persistence details. It knows that there is something about repository, but it not only knows about interface of this class, of this object, doesn't know about the implementation. And because we don't have interfaces in Ruby, we use duck typing, it's a bit harder to imagine. Now is the important part, strategy DDD. It's about bounded context. I don't like the name. For some reason, domain-driven design is all about naming stuff in a good way, but they introduce names which are hard to understand and hard to remember. So we like bounded context. It's a different, weird name. I would call it module. It's something. So usually when we introduce services, repositories, we are building layers. And bounded context is like we are splitting our application like that. So those are modules. So we are trying to find different business concepts and separate them, isolate them this way. And we do it by definition, we do it by drawing a context map. So we will be talking about drawing a bit. So yeah, we don't like UML because it's like Java and we hate Java, right? Martin Fowler, he's always the best source of information. The colors are maybe not so clear here, so this is like a bit more blue, this is a bit more red. Those are two different contexts. The line is in the middle. And they both, so this is support context and sales context. In our projects, usually they are kind of mixed. And when you see this diagram, we think, oh, I would do it this way. Obviously, I would separate it. But then when I looked at these hundreds of Rails applications I saw, no one actually does modules. Those are candidates for microservices as well. But the important part is that some concepts will be repeated. So if I see some approaches to modularization in Rails applications, we tend to do modularization around a resource. So we call one part products, other part is customers, and there is opportunities, campaigns. So we try to organize this, which is usually not the perfect way, because those are the bigger concepts here. Support, customer support. They submit a ticket, they tell us about a defect, they tell us they've introduced the product version information. While in the sales context, we have a pipeline of leads, you have opportunities, salesperson, but two things are common. They are shared. And it's okay. In this case, actually, they even have the same name, but they live in different places. Often we have things that have different name, but the identity is actually the same. So we're always talking about the same customer, the same product. How many of you work in something called software house, development agency? You work for external customers? Other work on your own products? No. Okay. Okay. Outsourcing is like also for external customers usually. So anyway, I will show you an example because I run Arkansas, and Arkansas is a software house or developer agency, whatever it's called. So maybe this word will be familiar to some of you. So we have human resources part, which is as developers we hate the name resource. We don't want to be called resources. That's right. But in some words, they use resources. We will never get rid of that. In some places, they will call us resources. But it's not okay to say, hey, resource, how are you? This is not the context you're using it. You're using the resources in like human resources or like someone at a very high level, they want to talk about resources. We have project management, so we have several customers and people are assigned to projects. So that's like a different word. We have finances, so customers pay us and we pay to developers. That's the finances world. Some kind of communication and invoicing, so we send invoices to customers. So those are the different concepts I would see if I had a software to automate my business. I don't have such software, so this is just my imagination. Now, why I'm talking about bounded context here? Because I believe that layers are good to introduce, but not everywhere. And it's a waste of time to introduce layers in places which have no business logic or no interesting business logic. Some parts of our applications can be CRUD, and we should be okay with Rails' way of doing this. Some places of our application deserve layers, so DDD Lite, I put the lines there. Like in our company, project management is quite interesting because we have many business rules of who can rotate to a new project, which people can cross projects, so work on 2 projects at the same time. So those are interesting rules. We also have history of who worked together and whether this cooperation was successful or not. This is interesting. So we have some rules. So if I implement this, I would use aggregates to represent a customer, represent a project, represent a developer. In finances, I want some logic because it's very important to me. In human resources, it's just signing a contract. There's really nothing so interesting. Another way of looking at it, those places which deserve to have layers are those places which are our business advantage. The way we send invoices to our customers is not the RKNC business advantage. We're not trying to be unique by sending nice invoices. We actually outsource it to an external service, right? For human resources, we just generate some PDFs. It's almost like CRUD. Nothing really cool. So those places are optional as microservices. Now consider this. If we implemented this as a monolith, okay, can those places be partially available? If the human resources application or the module goes down for some reason, can we have project management to work? In some implementations, I can imagine this can work, but in some others, they can't. Like if the project management queries the human resources for the list of current employees all the time, then we depend on that. Human resources can't go down. But if we duplicate the data, and when human resources says, this developer signed a contract, that's an event, interesting, project management goes up and says, okay, I will persist the data. This is interesting to me. I want to persist it and be independent of everything else. So then when human resources goes down, I still have my list of employees of developers. And developer, project, and client would appear almost in all of those words. However, I would persist them in all sides separately. So we have a lot, in this concept, we have quite a lot of data duplication. And this brings a problem of data synchronization. So we need to synchronize. Just to go a little bit down to the code, bounded context can be represented as namespaces, so modules in Ruby, module invoicing, module finances. And then use this as the things inside, whether it's a class or just a method, use it as the main access to this part of the application. Okay, so how to get there from legacy? So we have legacy as a monolith and everything is coupled to this kind of separation. And what kind of things you can avoid by doing that. So draw the context map as this is reflected in the code. And this is actually what domain-driven design called a model. This is a model. We call it database records. So draw the context. Now is the important part. It's a waste of time, as I said, to introduce layers in a boring parts of the application. And we've made this mistake, so I'm saying it being very sad. We introduced layers in parts which were really CRUDs, and we spent too much time working on this part. Wasn't worth it. But there is one addition. Even if you stay with the CRUD way of thinking, some parts of your application need the CRUD parts. They still need to notify other parts that something interesting happened. So like if you created a new contract in the human resources, they publish the contract signed event. So it needs to be extended. So it's not as CRUD as usual Rails applications. Some more examples in the ticketing platform, inventory. Like the idea that an event has 30 tickets to be available is worth being separated because it's already kind of a logic. So from the inventory point of view, they have items, not tickets. You can use more specific language sometimes. Sometimes it's worth it. You can even imagine that this inventory, if you separate it from a ticketing platform or from an e-commerce application, it can be reused in the context of other applications. So you can put it in a gem, you can keep it in your company or make it available for other people, and this can be actually reused because it's no longer coupled to the other parts of your application. Invoicing. Yeah, that's like a different concept. Ordering, finances, forum. So we can use some kind of race engine for forums. Maybe we can use Discourse and communicate with that. So you can just separate those worlds. Now, this is an ongoing process. No one is going to give you 2 months to a rewrite. It's not going to happen. So even if you want to introduce some DDD in certain places, you need to do it gradually. That's the problem, but that's also, I think, the responsible thing to do, because you can control the risk along the way. Now, the most troubling problem is people, us, developers. If one of you in the team wants to go DDD and others they don't have to be opposite, but they don't see the motivation, they don't understand the need, maybe, you will have conflicts, you will have disagreements, and this can sabotage the idea completely. You can actually, if you try to introduce the DDD with one person, with you, or maybe 2 friends and the other wrong people, then you will sabotage the project. That's the risk. So it's better to make sure that everyone actually wants to do it. And if they don't want to do it, it doesn't mean they are bad people. It means maybe they're right, maybe actually think about it, maybe they have good reasons, but maybe they just don't agree, they don't see the needs as much as you see it, and it's better to explain it maybe more deeply. Another recommendation is to escape from the CRUD verbs. So if you talk to business people more often, you see some verbs being appearing that they're not creating a user. They register a user, right? So if you have the idea of managing events, for example, you register a user. So it's a good start to turn all those create, destroy. So you're not destroying a user, right? And we use this verb.
It depends on business.
Yeah. Now we're actually going a bit away from Rails things. Convention of the configuration. The thing that made us fast at the beginning, in the first weeks of development, this is making us problems later on. The dependencies that we are, I don't know, even the fact that the render view call in the controllers is hidden, is implicit. This is one part of problems when you want to try to turn some controller action into a service object. You need to turn more things to be more explicit. Test coverage. Test coverage, because you are going to change code and you will break it if you don't have tests. Now that's obvious. When you're a client, you don't like regressions. The story about imagine you go with your broken car to the mechanic and you want them to fix your brakes. Next day you take the car, brakes are okay, you try it, so you pay, you thank, and you go. Nice weather, nice music in the car. So you want to open the window and it's broken. And it was working last day, right? So the mechanics, they broke the brakes, they fixed the brakes, sorry, but they broke the windows. It doesn't happen that often, right? But this is what happens to us every day or every week. And we have lots of nice excuses like, oh, I changed this code, yes, but it wasn't my code. Someone wrote it 1 year ago and, everything was great, but there was one part that I forgot. But it's not my fault. Or this is actually close to a better argument, but still I don't think it's very responsible to say, yeah, I changed the code, but the tests passed. I'm okay. So let me rant for a while about test coverage. you're using rcov or simplecov or using those tools that wrap them. I will not mention them. But this is a joke. This is not really covering our tests, our code really well. So if you follow my blog or the RKNC blog, you know what I'm talking about, mutation testing. This is, yeah, you can clap louder. Thank you. So this is the real test coverage, I think. Or maybe differently, this is a closer to what we call test coverage. So this is actually taking your code, it loads it to a memory, parses the code to abstract syntax tree, changes one node of the code, and it runs the tests again. And the test should fail. To make this name more explicit, by changing one node in the abstract syntax tree, we are creating a mutant. And we want to kill the mutant with the tests. So if you change a code and no tests fail, then the coverage is not full. I'm not saying this is a good bet. I'm just saying that the coverage is not full here. So you may want to add more things. So you want to try mutant. I think you want to try mutant. Try to run it on your code base. It's very cool to actually watch how it changes your code because it puts a nice display, a nice output. So in a way, mutant is testing your tests. And then you learn your real test coverage. So if you think you have 80%, in fact you have 8%. This all gives you refactoring with confidence because you have now a real test coverage and not the imaginary one. Another thing is if we have Rails specific classes like controllers, models, views, and so on, if we treat every class as a unit and we write tests for each class in separation, then we are actually making the code harder to change now. Because going DDD means splitting classes, splitting objects, merging them sometimes, changing them. And by writing tests for each class, you're basically required to change every test. And if you're changing tests, you are now at the danger that you decrease the test coverage and you're actually risking more. So what are units? Sometimes it is a class, but more often it's a collection of classes with some top-level API. Now, Rails. We have controller, and in order to go DDD, we want to decouple from Rails as the first step usually, so that we can actually think about this world of invoicing, not at the HTTP level. We want to think about it at the library level. So Rails is just a front end for us. They call us. How we modularize it under the hood, it's a different part. So yeah, Uncle Bob said, Rails is not your application. So I think that's part of the meaning, that Rails is just a wrapper for you. It's just something that calls you. But Rails is actually very good with dealing with HTTP. Perfect. Rails, rack, good things. So we don't want to move HTTP-related parts to application services, so to the next layer. This is HTTP. This should belong to the controller or to middleware or something like that. Next, don't just pass the parse harams everywhere. I'm not saying this is always bad, but this collection of params that we pass through all the layers is not the perfect thing. So it's better to have specific objects for each of the layer boundary. The whole idea is called data transfer objects, DTO, and for each boundary you want to have specific objects for this DTO. I know this is a lot more code that we have in Rails. This is a problem with the whole approach. We will create more code. So if this is your metric to determine if whether code is better or worse by having more code or less code, so this is worse. We will have more code. But the code is more explicit. So now you need to make decisions whether it's worth it. So every time you pass a param through the layer, so inside the layer it's okay. So you can use hashes and so on. But when you go through the layers, you want to have a wrapper for that and validate the input, for example. Some of your banded context will stay the old way, but it's nice to wrap it with application services. Don't go repositories, don't go any other layers, but this is the solution to the infinite API problem. So that you don't need to call the models directly, you use some kind of a wrapper above. Use events to communicate between bounded contexts, because somehow they need to communicate. So even it's nice to say I have inventory being separated from ordering, but in the end, when someone orders a ticket, we need to take these tickets out from the inventory, right? So they need to know. But this can be in the bus, event store. We created Rails event store to make it a bit easier to plug into your application, but the idea is very primitive. It's just a table with events, the domain events idea, and we have some classes to subscribe to certain events. When your application starts, we make this wiring, so inventory is interested that someone bought a ticket, so that it can subtract. So you can try a Rails event store in your existing application to start collecting events, and then you will see how to use them. Some people say, like, do you know CQRS? Anyone heard about CQRS? Command Query Responsibility Segregation? Okay, so this is very closely connected to DDD, but it's a bit more infrastructure approach. The idea is to separate your application to reads and writes. It's a nice solution to scaling problems, but it's also a nice solution for modularization. However, in the DDD world, many people are saying that it's good to go async. So when someone buys a ticket, we publish an event, and somewhere there, sooner or later, the inventory will subtract the ticket, so subtract the item. If we are doing it the typical Rails way, you are living in one Rails transaction, right? Because Rails gives us those transactions at the beginning of a request. And this is a good thing. We want to be consistent. We want to live in a transaction. So if we go to the async way, like a background job is doing some parts of the work now, the publishing of the events, or we have some proper event store, because the Rails event store I showed you is a very sync approach. So if you go to a proper message bus, things will go now very difficult. So it's better to stay sync during the refactoring process. Yeah, so this is the part I was talking about, CQRS. It's an interesting thing. It took me, I think, 2 years to understand. The idea is basically simple. You separate reads and writes, but the consequences of that are very weird. The idea is not just to separate functions. You use different objects for dealing with writes, with commands, different objects with dealing with queries, different classes. Eliminate querying from one bounded context to another. So this is solved by the way I told you about data duplication. So when you have one world that wants data from other world, and this is especially relevant to microservices. If you want to have them in different parts, you want to decrease the number of queries that are made. One, conceptually, because it's coupling. If you make a direct query, it's coupling. But on the second part, it's also not efficient if you would go microservices. So the idea is to push the data, push the event. They subscribe to the event. They persist the information they need from that event. They don't need to persist everything. Like the inventory is just a counter. So you don't need to persist everything. Yeah, so once you have those different bounded contexts, you need to keep them in sync on any service, on any event. So if someone bought a ticket, that's nice, an event, but then they refund the ticket, they cancel the ticket, you need to notify everyone who was interested about buying the ticket. So you need to do this subscription. It's much easier to test when things are not dependent on each other. So if you have suddenly, if you want to just test the inventory logic, you no longer need to create a customer, you no longer need to create an order, you no longer need to create even a price for the ticket is no longer relevant. So your testing setup for the inventory is like create item, subtract item, look at the counter, that's it. So suddenly you are able to separate things to different words and test them separately. The logic now is moved a little bit to the event wiring, but that's more declarative. You can still test it as well. It's a bit easier to test in separation. Read models, reports. We were hearing good things about reports today, and reports are good candidates for read models. Read model is a concept where you have like a report. It doesn't change data. It only consumes some data and then displays it. That's all it does, a read model. Read model is one of good places if you have some reports in your application or any kind of interesting view to your application, to your data. It might be a good idea to treat the read model as a bounded context for a moment and have it populated with events. And then instead of querying the data needed for the view or the report, you just dump the current state you have in your bounded context. Aggregates. I'm not going to explain details. Go to any DDD resource and read about aggregates. Nice way of thinking about your application. Aggregates are useful only when you need to keep some constraints in your application, like a developer can't change can't change more than 5 projects in a year. Good business rule. You want to have aggregate to keep this rule. Okay, I'll skip this part. Event sourcing. Now, when you collect all those events that happens in your application, you are now, at some point, you will reach a level where all the data can be retrieved from events. And that's a nice thing to be. You can now actually have your aggregate, your whatever state you want, built from the events. So you're changing the way of thinking now. You don't use the snapshots of data anymore. And by the way, it gives you audit log for free. This is a nice side effect of this approach. When you're using events and you store those events, you can know everything that the user did in your application. Audit log gave us a lot of money indirectly because we could prove that the payment gateway had bugs. And we could show them the different series of things that happened and why they charged more than was needed. Again, distributed transactions are not easy. So if you go microservices too early, suddenly the problem of transactions, which is nicely solved in Rails applications, is a new world of problems. You can't easily roll back in different microservices. Yeah?
How do you do distributed transactions in Rails?
So I'm not saying that, sorry, that was a mistake. I'm not saying distributed transactions are solved in Rails. I'm saying that transactions is solved in Rails. So if you do thing in one transaction, it's easy. But by making things into several microservices, now you have the problem of distributed transaction, which is not so easy to solve, right? So there are some algorithms that deal with that. But the DDD recommendation is always to think whether you really need the data to be consistent and what happens when it's not consistent. There's this example that you may be selling luxury yachts and you have one yacht available, so people can buy the boat, nice ship, and for some reason you have distributed transactions and somehow you sold 2 yachts. So a bit of a problem, right? However, it's always specific to the domain you're working in. If you go to the owner of this yacht factory and the yacht was €1 million each, then they are happy. 2 million euros, great. It's a nice problem to have. I will build the ship. I will contact the customer. I will find a way to build the ship. Maybe it's a bit later. I will give a discount. But it's nice to have the money. It's nice to have this decision to be actually made. In some domains, in some words, it's totally okay to be inconsistent. Set up the project, the one bounded context, the one microservice. So fix the bug, and that's it. So no longer the need to setting up the whole Rails monolith with all those different concepts being mixed up. This is now nicely separated. What kind of books do we have in the DDD related things or refactoring? So many people recommend Blue Book, but that's the one I told you about at the beginning. So that's the domain-driven design by Eric Evans. It's a good read, but I would suggest starting with implementing DDD. Warning, it's Java code inside. But it's a nicer way of explaining DDD than Eric Evans does. So implementing DDD, that's the name. It's written by Von Vernon, one of the DDD specialists. And the classic books, I hope you will read them at some point, or you will read them, Refactoring by Martin Fowler, and Legacy Code by Working Effectively with Legacy Code by Martin Feathers, who is the expert in legacy code approaches. So to summarize, Rails legacy projects, problems with dealing with slow tests, and so on. DDD as a way to consider to apply when you see some problems and you consider some layers. I'm not saying this is a silver bullet. It doesn't solve all your problems. But it's nice tool set it's a nice tool set to have, to apply it. And that's it. Thank you.
Can the code which is written using DDD approach be legacy?
Can it be?
Can the code which is written using the DDD approach be legacy? And what to do in that case?
Apply more DDD. No, of course it can be, yeah. So it can be bad code, it can be written yesterday or by someone else. So even in the DDD world, you will see people following Greg Young. Greg Young is one of the leaders. And then there is Udi Dahan, another person important in this community. And they have some slightly different ideas how to apply CQRS and DDD together. So probably the people from those two different fractions will complain about those code being legacy. So this doesn't solve the problem of bad code, but I think it modularizes it a bit better. So at least you have the code in one place, maybe.
May I ask?
Yeah?
In your company, who decide what the contexts are? So how many the contexts are in your project, and what the contexts are, whether they are code or whether they should use DDD approach? Is it better to do just one person to avoid additional discussion regarding that matter, or it's better to decide involve the whole team?
I think it depends on your company culture. So if you have like very equal, no managers thing, then better if they all come up together with the idea. If it's a huge team when the hierarchy is needed, then maybe it's better if some kind of a leader helps deciding, suggests. So for example, we try to have this kind of equal thing, but I'm often suggesting, like, you see this thing is happening here and here and here, but it's together with a code that is not related. Maybe it deserves a bounded context. So I'm also not sure, but I'm suggesting. So I'm kind of a leader here. But overall, the idea should come from developers. And now is the funny part. When you talk to DDD people, they always say, I just said it today as well, listen to domain experts, what language they are using. But the domain experts, you know what? They learned that when they talk to developers, they should use CRUD. It's faster. Yeah? Why should I explain? Complicated words, you just create, you just read, update, destroy. So they are using CRUD, and that's I think, a wrong path. But yeah, overall, try to read the domain experts' things, your customers usually, or some kind of people responsible for certain parts. But try to observe what they say when they are not talking to developers, when they talk to each other. What verbs do they use? What subjects do they use? What kind of processes they talk about. Basically, in this kind of enterprise software that we usually work, like ticketing platform, e-commerce, the bounded contexts very often represent the different departments in the company. You have invoicing, probably you have human resources, you have finances. Those are the specialists. So one way of looking at it is to see the customer company and see how they are separated.
They can be discussable. For example, somebody can thought that the HR department should use DDD.
Yeah, so at some point it's not clear that this will help you with the decision, but it may help you enrich your vocabulary to use in the code base as well. So the code base, the idea of DDD is that the code base should reflect the real world. That's the message here. That developers should use the language. They call it ubiquitous language. It's difficult to remember this word. So they call it ubiquitous language, and each bounded context should have their own ubiquitous language. So this means that some cases in the customer, for example, might be repeated as the name they use, but for some places, actually, the customer is also called differently. So you have different words representing different things in the different words. So bounded context, when you think it's a good idea to separate it, is whether there is actually a different language being used. That's something that's worth considering. Yeah.
I have a question about this. When you suggest to go away from the monolithic application architecture to some microservices, You didn't tell that this switch will bring a new problem, a problem with integration, because it's quite often when you test the things separately and they work well, but when you join them together, they don't work at all. How to deal with this? And also a good point to think, how to test all this architecture, because if you test separately and you need to be sure that all together is working, you duplicate some microservice testers.
So starting from the first one, this is why I'm actually not recommending to go microservices very early, because other than the integration problem, it brings you a new infrastructure problem, deployment problem, and so on. It's also for testing problem, so it's difficult to test two microservices together. I'm not saying it's impossible, but it's more difficult. So what I'm saying is, for example, you can consider that different bounded contexts can use different databases. And this is something is a good idea later on, but I have no problem with everything. So bounded contexts should have their own data, their own persistence, conceptually, but physically it can be the same database. It's just important that they don't look at each other tables. So that's a nice way of separating it. So when you keep things sync and not async, and you use the same database at the beginning, then it's not so easy to actually test those things together. You can do it. I'm not saying this is forbidden to test at integration level. I'm just saying that now you are enabled to test in a better unit test level. This is now easier, but still, if you find it very important that ordering and inventory should be tested together, you instantiate both modules, both bounded contexts.
Another question, it's more really specific. You told that it's better to place some bounded context in namespace. Have you tried to use engine, which is provided by Rails, when you can, I guess, to concentrate some specific code in some engine, and then your app is just collect some engine together and because it's somehow is the same, but it's microservice at the development. So you are thinking like it's microservice, but when it became work, it's became one monolithic application which don't have the problem with communication.
So Rails engines, I don't think we ever tried. We often were thinking about it. It should be probably okay as a way of separating. It's just I don't like this idea that Rails engines can also come with views and controllers. The idea with splitting bounded context is below controllers. So I want to find a way of separating everything below controllers, and engines give this to us, but they give us out more, which I not needed. So the idea is more about putting things like /app/invoicing, /app/finances, than it is to go totally separate. Again, if you keep the code from different bounded contexts in different repositories, this is a physical separation. It's not conceptual separation. So first start with conceptual modularization, conceptual isolation. So put things in different namespaces is the first step. Put things in different directories might be another next step. And then maybe you want to turn those things into gems. But this is like the later phases. You probably don't need it at the beginning. And it's much easier to do it in small steps at the beginning. It's a bit safer.
What is the best selling point in migrating to DDD? Because if I understood right, you often deal, a customer comes to you with a legacy code base, and after analyze, you suggest them to move to DDD, but what are really the most effective selling points?
The nice thing about specializing in taking over existing Rails projects is that they are already in deep troubles.
Okay.
And they come to us because we can be seen as someone who knows the solutions, and they will trust us. So that's easier. I know this is like a specific situation, but overall it's just focus on the problems they have. And if they don't see the problems, then maybe DDD is actually not worth it here. So just mention the bugs, the money they're losing, and so on.
But another situation, when you have a project from the beginning, it was a monolithic application, and at some point you're starting to realize it should be applied there, and it's quite a lot of extra time. What's the best selling point?
Stay with the monolith and make those little changes only. So the idea is not to try big bang refactorings. No one is going to agree on that. The idea is to learn some more techniques, learn about DDD, so learn about the end goal maybe, and learn about the road. So learn about how to, with every commit or every pull request, you make some changes which gets you closer. So you're not there, but you can see that you moved. So from A to Z, you moved from A to B. You can see it. And that's also why it's important to communicate with the team and have common understanding, so that the other people can see that A to B, looking at it from like only from this transition, doesn't necessarily make sense. But if they know it's part from going from A to Z, suddenly it's easier to communicate. So like at RKC, we have common way of looking at the code base. It's not like unified, but it's very similar. So we can just say, okay, I see that the controller doesn't pass instance variables to the views, but they are passed by render view with locals. I know that in separation this change is weird, but we learned that it's much easier to introduce service objects when the view gets data directly, not by instance variables. But this is just like a small thing, right? So it's, yeah?
You said that Rails is mainly optimized for work with DDD. Do you know any framework that works well with DDD and has some stuff that making it great for DDD?
No, and I'm not even looking for this kind of frameworks. Maybe there are some, because
So you shouldn't say that frameworks like Rails is bad with DDD. You should say that all frameworks are bad with DDD.
Yeah, but I'm talking about Rails applications today, so. Yeah, but I agree. So everything is bad. So the idea is that Rails itself is not bad. The problem is mostly in developers overusing. And again, I'm not really hating Rails. I'm hating the so-called the Rails way. So I'm not friends with DHH, for example. And he probably doesn't want to be friends with me. But I'm okay with that. I'm not saying that the Rails way is always wrong. For some parts, as I said, it's okay. It's totally fine. It's just in some places of the application, you may want to go away from the Rails way. By the Rails way, I mean using the typical way of modularize and so on. So just in some places, you may want to be better without the Rails way. Another question?
We understand that there is no silver bullet in communication of those microservices. But still, what do you suggest using event-driven architecture or some kind of RPCs or HTTP requests while communicating between those units, modules?
Yeah, this kind of architecture, if you go microservices and bounded context, I think it's the best way, in my opinion, is to go with events. So event-driven architecture. And infrastructurally thinking, you need some way of passing the events, being them persistent, being them published. So we need some tool set that enables you to trust it, right? So if you publish an event and it was published, you know that it was persisted as well. So it's important, like all those RabbitMQ, those are the tools that we are talking about here.
By the way, can you suggest any continuous delivery framework to manage all those integration testings, which is quite convenient?
I'm not really a specialist here, so I love the idea of continuous delivery, and I love the idea of bounded context being separated at the conceptual level. I'm not really a microservices expert out in the infrastructure level. So the way we are using it is, for example, for some projects we use Jenkins. When it runs tests, all the tests you can deploy to production. But in some cases where we started to introduce the bounded context at the code level only, we recognize whether which part of the code base was changed, and it's only this one. The tests only for this one are running, right? So it's like we split it at the script level, we can say. But there are probably some better solutions.